1-1. Cartesian plane. Yesterday, we just barely started talking about it. So let's go ahead and start talking about a few things that you see up here. Now, first of all, how long have you been learning the x and y axis for? Oh, really? I was thinking like math 6, maybe earlier. I don't know. But you've been learning it for a long time, right? Plotting points. So when you see this example, you're like, seriously? We're starting here? Okay. In my experience, and maybe it's just me, but in my experience, the harder math I learn, the harder the easy stuff gets. Hopefully false. Hopefully false. But in my experience, as your brain starts dealing with more complex concepts, sometimes the easy stuff just escapes you and you're like, or you plot, and I'll admit, in the last 2 years, I've definitely plotted a point in the wrong place in front of students on a smartboard. I know, right? It's horrible. You might too, at some point. So it's not bad to practice, plus we're thinking through in this section maybe concepts a little deeper than you have before. First of all, up here, Cartesian plane, it's also called the x and y axis, the Cartesian coordinate plane, rectangular coordinates, so many different ways of describing the same thing. What are some things that you guys already labeled? Quadrants. Quadrants start where? Top right-hand corner, and they move what direction? Counterclockwise around. Do you remember anything from last year, hopefully? Some of you, how many of you took Algebra 2 over the summer? No? Okay. What uses quadrants specifically? Unit circle. So anyway, quadrants, good to know. Quadrant 1 and 2 and 3 and 4 usually denoted by Roman numerals moving counterclockwise. Okay. What else? We have the horizontal x-axis. However, something just to think about. How are the tick marks on the x-axis oriented? Vertically. But it's a horizontal axis, right?
Oh, yeah.
But the tick marks are vertical. Pause. Think about it. Question. How would you graph, just a quick extra, it's for free. How would you graph x equals 1? Go to the x-axis, go to the 1, and ask, which way is the tick mark going? Follow the tick mark. X equals is always a vertical line. Something from pre-algebra that we always forget. Not we as in everyone, but we as in quite a few. Question. How would you graph y equals 1? Or think about it. How are the tick marks on the vertical axis oriented? Y equals 1 for that entire horizontal line. Now, if you had Mr. Shanks, y can fly. Yeah, that's true. However, in case that didn't stick very well, you can use the tick marks to help. And I'm going to probably reference that a few times this year, because believe me, you're going to forget. Hopefully not permanently. Hopefully it's just like one of those, it's been a rough morning things, but there we go. What else is up here? The origin. We know that all the quadrants are perpendicular to each other, so they're at right angles, yada, yada, yada. Okay. How many of you guys have already plotted these points? Okay. If I look at your graph right now, am I going to be able to tell by the way that you plotted it exactly which one is which? You have to go through and label every single one with like a parenthesis, a number, and a comma, and a number, and a parenthesis. Or, let's be smart about it, and let's use variables. This is something somewhat algebraic after all, right? If you haven't plotted the points, do so now, and if you haven't labeled them, just use ABCD. Too late to label? Not so sure about that one. Not too hard to write your ABCD. And in just a second, I want to know where those points are located one by one, but I do not want you to tell me. It's just there. You have to describe it to me. For instance, letter A. Yeah, kind of, right? Battleship totally uses Cartesian points. Letter A. Where is it?
Down 1 over 2.
Down 1 over 2? Not enough.
Down 1 left, right to the left of 2.
Yeah. X is the horizontal. So we need to go left 1, up 2. Struggle. What quadrant is it in? Quadrant 2. So on letter B, let's start with the quadrant. What quadrant would letter B be in? All right, focus back on in. I already admitted that I plotted points in the wrong place before, so come on back up. What quadrant is letter B in? Quadrant 1, good. Describe where the point is. Right 3, up 4. Can I plot it even though it's not there?
No.
Oh, come on. Yeah, we can. Letter C, what quadrant?
Origin.
All of them, kind of. Where's it at? Origin. That's the easiest way to describe it, right? Or you could say right 0 and up 0. Letter D, just kidding. What quadrant? Which one? It's like in between. All right, describe. Where is it? Over 3 and up nothing, right? The x-axis, another great way of describing it. A, B, up. I didn't label C, D. E, where is he? Quadrant? We should know that real quick so we see a negative and a negative, right? But, yes, quadrant 3. Describe. Left 2. Nice. A, B, C, D, E. Are we good? All right, let's keep going. Something so basic, I know, but I wanted to hear it a bit more. Yeah. 2 things from the past. 2 more things from the past, I should say. First of all, Pythagorean theorem. Pythag geometry. It's an important one, right? Without even the picture, you guys should be able to state it for me. What's the Pythagorean theorem? Have you ever seen it geometrically demonstrated?
No.
Yeah, with the actual squares?
I think we're about
Super cool, if only we had time. If only we had time. However, real quick, apply it for me. Pythagorean theorem only applies in what kinds of triangles? Right triangle. It has to have at least one. Wait, can a triangle have more than one right triangle?
No.
Because 90 plus 90 is 180. How many degrees are in one? I need a third angle in there somewhere, right? So a right triangle, A and B, we would both describe by being a right triangles. How do we describe those sides? Legs, thank you. And then letter C is the hypotenuse, true? Question, does it really matter whether that's A and that's B or that's A and that's B?
No.
No, but does it matter that's C?
Yes.
And C is always opposite the right angle, true? And C is also always the longest side. You guys don't like to finish sentences. That's okay. Let's come down to the distance formula. If I were to have a quiz, one question, worth a test grade right now, and ask you the distance formula, how many of you guys would get 100?
You know, I don't know my.
I have like 5 confident ones. 1 shaky, so maybe 4 confident and 1 shaky. The rest are just out.
Give him the test.
Now, wait, pause. Distance formula is the Pythagorean theorem, but let's talk it out. So if you know the Pythagorean theorem, almost all of you are like A squared plus B squared is C squared. Easy. Distance formula, suddenly got hard. But wait. Let's not go straight to D equals the square root of, even though that is the one you've probably memorized since forever ago. Not really, like 2 or 3 years. Let's come back and say, hey, it's really a picture and D is that. What is that? What else is that? A hypotenuse. Hypotenuse for what? A right triangle formed by the difference in the x coordinates and the difference in the y coordinates. Huh? If we were to think of our 2 points, x1 and y1, does it really matter how I label them? No. You can choose that to be the first, that to be the first, that to be the first, that to be the second, whatever. If I think about those 2 points, look at the tick marks that show the boundaries of the bottom leg. Okay? This would be technically x1. This would be technically x2. Right? So how would I find this length? Subtract them. If that was 8 and that was 2, that would be 6, right? I just subtract them, pretend they're numbers for a bit, and maybe it'll make it a little bit easier. x1 minus x2 is the length of that leg. Now, what comprises or what shows the boundaries of this side? Height 1, height is a y, height 2, right? How do I find the length? If that was 10 and that was 3, this would be 7. I just subtract, right? Nice. So then, before we ever get to this weird square rooty thing, we can be like, haha, it's the right triangle. So we do leg squared plus leg squared equals hypotenuse squared. Then we just solve. Ricky.
I thought you're not allowed to. I thought x1 and y1 have to be corresponding.
Hold on. We're getting there. But good question. Hang on to that. My next question is, what's wrong? And Ricky just pointed it out. They're different. Mathematically, think through with me though, in this context specifically, does it actually make a difference? What would happen if I did our old example, 8 and 2, 2 minus 8 instead of 8 minus 2? It would be what kind of number? A negative. But a negative squared doesn't make a difference. Now wait, just to be formulaic and to go back to the formula that you guys memorized forever ago, sure, we'll switch it around. I don't mind. Totally fine, right? But my question was, did it actually make a difference in this context? No. Could I have written the y subtraction squared before the x subtraction squared? Yes, addition, it's commutative, doesn't matter. But what formula does, Ricky, you're right, it does matter somewhere. What formula does it matter? Look, y2 minus y1 over x2 minus x1. It doesn't actually matter which point is which, it matters that you keep it going the same direction so that you have the proper sign. Because there's no squared in slope. Now if we finish this off, we do get our good old-fashioned x2 minus x1 quantity, squared, plus, that x1 has issues, hold on. Like he has a beauty mark. Okay, so, there we go. That is our traditional formula for distance, true. But you don't necessarily have to memorize it. It's more understanding it. With that, let me come down to this example. Depending on how your brain works in your beginning of the year, let's get the year going form. I think you tried to answer for me what kind of learner you are, and some of you have no clue. Maybe this example will help. So I'm going to do it 3 different ways. One is like jumping around and making or solving it more logically. One is following that formula to a T. And the other one is let's draw a graph and picture. You guys just choose a way right now and solve it. If you haven't even seen all 3, just choose the one that you would think you should do or the one that you would think makes sense. Remember, if you need to change to a new page, feel free. You can go to the page right behind. That's page number 2. Make sure it's labeled. Or you can skip a page and then use a lot of paper. You can do it. I won't mark it down. Just make sure you keep labeling this page. If you're most comfortable plugging it in straight into the formula, that's fine, but I'll show you the other 2 ways in just a second. Get there already? Can we simplify that radical? If we can, we're in trouble if we don't. Unless it's a word problem, then maybe we can go to decimals. 34? What things go into 34? It's even, so 2 does, right? How many times? Mental mathers? Say it louder. 17. 2 can't break down, 17 can't break down, so we're done. That was kind of more logically. Thinking in terms of change in x, change in y. Okay, there's 5 in between the x's, 3 in between the y's. Pythagorean theorem. Strictly following the formula. You would go ahead and start labeling stuff probably and think of whether or not you actually write it x1, y1, x2, y2. We've gone to your little parentheses. You would have written out everything. Still totally fine. To be honest, you'll probably make fewer mistakes than the logical person that skips around a lot. They might do some problems faster, but hopefully you'll make fewer mistakes because you're showing all of your steps, something that Crawford, I know, capitalized or emphasized. Mr. Park, I'm not sure. But then coming back on down. You would have then hopefully seen minus and negative would be plus. 3 plus 2 is 5. You kept showing all of your work. If you're doing PEMDAS correctly, hopefully exponents before addition. Hopefully you would have ended up in the exact same spot with the exact same answer. Just a few of you visual people out there. It might have actually been easier to do this the good old-fashioned, let's make a picture way. Then you could have said, hey, sure. What's so off my orientation? So much judgment. You would have counted a 1 and a 2 and a 3 and a 4 and a 5. Hey, this side's 5 long. You would have counted a 1 and a 2 and a 3 and a 4 and a... What did I do wrong?
You went down one.
That pointing plot thing. You guys didn't believe me, did you? Okay, coming back. Point proven. Let's go back to the problem at hand. Negative 2. Positive 1. Thank you. 1 and a 2 and a 3. Hey guys, 1 and a 2 and a 3 and a 4. This problem, how long does this one take?
Forever.
Okay, thanks. Normally, how long did it take me to set up this triangle and then count 1, 2, 3, 4, 5? He's 5 long, 1, 2, 3. He's 3 long. Square root of 25 plus 9 equals my hypotenuse, which is my D. Not long, right? So when I messed up, maybe I'm trying to show or prove another point as well. When I messed up, did it really take me that long to recover? No. Do you think as we go on in pre-calculus, there might be longer problems? And if you see a mistake, and I go for like 10 more minutes solving a problem, and then we have to start all over again, realistically, who's it on? You guys. Now, does every single one of you have to catch every single mistake? No, I don't either. We're imperfect people. Hopefully, we'll be able to grow despite our weaknesses. That's kind of the Christian life this year in math. But just let me know as soon as you see it, okay? And if you're wrong, no big deal. I'm wrong sometimes too. Okay? Ready, set, and visual people, maybe you're like, I like that way. I'll never forget it. Those of you guys who are like, I like this way. Well, you better memorize it and never let it go. Here we go. One more thing. Midpoint formula. What am I trying to prove? I meant the whole lesson, but we'll get back to that right at the end. Trying to make a few points. Hopefully they stick. Those of you that are punning, that could be kind of funny. Midpoint formula. If this was the one question on the test that I gave just now, how many of you guys would be like, 100? Oh, fewer than the other one? No way. Midpoint, you're trying to find the middle, right? A line segment cut in half, the very middle of it, wherever it is, whether it's tilted and it's comprised of two different slanted, diagonal? I don't understand. Whether it's horizontal, whether it's vertical. Where's the middle? Now, hold on. If it's a midpoint, it's a point. And if it's a point, what does it have? Has a coordinate, right? Has an X and a Y. Okay, well that's easy. If it's a midpoint, it's the middle of a line segment, and a line segment has how many points? So you have to be given some sort of x1, y1, and x2, y2. Now hold on, pause. I asked you guys how many get 100 on the midpoint formula, and I had like 2 hands, maybe 1 and like a half. Someone was still deciding. Here's a different question. How do you average stuff? If I give you lots of numbers and tell you to find the average? Question. More people answer than the other one, right? More people answer than raising of the hand. They're the same thing. How many points do we have? What do we need first? So if we only have 2, then we add the 2 and we divide by
2.
Oh, we average the x's. How about the next one? Probably don't? No, probably do. We have 2 y's. Find the average of the y's. We have ourselves the midpoint formula.
Less.
Ready, set, example, go. You know what an average is. Don't you ever forget the midpoint formula. You know what Pythagorean is. Don't need to forget the distance formula again. Doesn't mean it won't happen. But hopefully for at least a few of you. You'll be a bit more comfortable. Blake, did you solve it? And mental mathers? I don't mind mental math. Just don't ever make a mistake. Oh. So in order to help you in the quest of never making a mistake or making fewer than you've made before, please show work. I like mental math. Sometimes we'll play things with mental math where you get dum-dums for doing mental math or being able to make connections quickly. That's awesome. Please show work. Fast, make sure you're right. So hopefully you guys took the x's, the first coordinates, and divided by. Sometimes it's even hard to remember which one's which, but either way. Take the first coordinates, add them, divide by 2 the second coordinates, in the sense of second in the pairs. And we end up with -5 plus 9, 4. 4 over 2 is 2. That's a good mental math jump. But maybe straight from beginning to end. It might look a little sketch on your homework. -3 plus 3 is 0. 0 over 2 is 0. Are we good? Visual people, you have to graph the line and do all sorts of things with right triangles. It'd be really rough. It would take a lot more time. So I'm not going to show the visual way. It's a lot of geometry. So, what have we covered? Everything Cartesian plane. Everything Pythagorean, not really, but just the beginning. Distance formula, midpoint formula, and we're going backwards. Done. Oh. Okay. Question. This year, could we be going over things that you've seen before?
Yeah, I like it.
Right? Now, this section is a little ridiculous. Don't worry, it'll get harder. I know you guys were so sad that this was going to be this easy, but it'll get harder. But will we see things you've seen before?
Yes.
Please realize some people are like, learn it once, I got it, let's go. Like factoring. Learned it once, I'm good. The majority of us are kind of like, yeah, the 110 was great. Can we have 2 or 3 or 4 more times of learning it, and then maybe it'll stick? Please, we're going to work together. We're going to collaborate in our groups. We're going to understand that different people are coming from different directions, etc. as well. And some things, maybe, every now and then I might offer you a different perspective on something that you've known for a while. Yeah? And maybe in a way that it might help you have a better understanding of the concept as a whole, as opposed to some random math fact that was thrown out that you had to memorize this one time. And maybe you kind of used it well on the test, and maybe it was awful on the test, but then no matter what, you probably just flocked it out and kept going. That's not true. So we're going to try to do a little better than that. Now let's talk through, I was mentioning, let's not do that right now. Let's talk through homework procedures. I had 2 or 3 of you that actually did your entire homework last night. The rest of you were kind of like, okay, tonight, right? We already talked about where to find the homework problems on the homework sheets online. What we did not, I don't think, tell me if I'm wrong, what we have not talked about is our spiral notebook. Have we talked about that one? Grab it out if you have it, and if you don't, take really good mental notes. Spiral notebook. I'm changing things up this year. You guys can be my guinea pigs. Hopefully in a good way. Okay, spiral. Guess what? I want name on the front cover somehow. And some of you are like, no, mine's like the smooth. Can't really write on it one. What do you mean? The Sharpie. You guys want to, real quick in your groups, be like, hey, who has a Sharpie?
It was
Hopefully yours is better than mine. Mine's like one subject with no pocket folders. If no one has a Sharpie, okay, you can make really good mental notes for tonight. You need your name. Mine's not near as good as yours, hopefully. You need your name. You need pre-calculus and period 2. All those things? I know. Mine's not as good as your guys's. Because last year I had them get chintzy ones, and we didn't use them as much. But this year you have nice ones, hopefully. With pocket folders. And remember, if you don't have pocket folders, you just need a folder to hold all your handouts. Or if you want to still have a binder, you may. I'm not saying you can't. Okay, I need a name. If it's dark, if it's like a black cover, put it on the inside. That's okay. I need name, I need pre-calculus, I need period 2. What is this used for? Homework number 1. No, it's a spiral. Yeah, I know. But usually you're not supposed to tear papers out of spirals. I know. So we're keeping it in the spiral? Mm-hmm. So where's homework 2? Or maybe, just kidding, not this one. But now wait. Think through with me. How many of you, somewhere in your academic career, have randomly had those papers just floating in your book? Just kidding, not floating. They're like packed, and then you can't find anything, or they're like in the book cover and they're hiding, and they fall out when you're like rushing through the hallways. Right? Seriously. This, just don't lose it. Like you're not supposed to lose your graphing calculator. Like you're not supposed to lose your composition book. Like you're not supposed to lose your textbook. Just don't lose your spiral. Okay? What else? Question. What if you're like, no, I do my homework the night before the test? What if you're like, I'm absent for a day? Why would you do a homework if you haven't done one before it? Because math does what? It builds. What am I trying to train you in? A, organization, in like a forced way. B, discipline, and like a do your homework the way it's supposed to be done, which is in order. C, what if I have a question on an assignment? I'll probably go over it the next day, so leave a little bit of space just like you normally would have done, right? What am I trying to keep you from doing? Half the homework and be like, forget it, I'll do it some other day when I have way more time. Never happens. You guys are like, what, sophomores, juniors? Junior years? Hopefully you get sleep on weekends. Anyway, so hang in there. Keep up with it. Do the best you can. If you gotta skip a couple, but don't skip whole assignments. It's just gonna hurt you in the end, and your poor spiral will just be a mess. Are we doing a table of contents? No, we're not. We're just starting with homework number 1. Now wait, if your name is on your cover, and period 2, and pre-calculus, what do you not have to put every homework?
Name.
Hey, extra time. Look at that. Now wait. What do I want you to put? Ready? First page, up here. Homework number 1. And more specifically, here, I'll model. Here's your like, and then there's your like. Okay, whatever. Homework number 1. Those of you that did your homework, just hang in there. Section, you can use my cool little interlocking S's. It's a math symbol for section 1.1. And then like squish in the page number and the numbers. Nah, put it over here. Page number. That's a little high. Start in the first line. First line, right? Page, numbers, da-da-da-da-da-da-da. Sound good? Now some of you are like, I did homework last night. Okay. Ready? We ran out of time yesterday. If you did homework last night, you have an option which is available to anybody in their notes at any time. If they forget something, you need to go back, or they were absent, or I have some complicated diagram that you really don't want to write down. Glue it. With glue? No, please, no. Glue stick, maybe? Sound good? Just take your paper and then just make it fit. And then whatever doesn't fit, go over here and then make it fit. I don't care. You can glue it. Just like if there's a complicated diagram in class, you can be like, I'll print it off at home, and you just glue stick it in. Saves time. That'll work. As long as it's not like one piece and it's like flapping and then it gets all glued. Yeah.
What if you're on both sides of the paper?
You might have to glue one and then like rewrite the other. Struggle. Or just rewrite all. Depends on your perfectionistic nature and whether or not it's actually. So I apologize for running out of time yesterday. That was a huge logistic that I meant to get to and I didn't. So those of you that did homework ahead of time, this is the one time it's going to hurt you on one of the easiest assignments of the year. So hopefully you're okay. Alright. Last but not least, you do homework. I know this is easy. When you do homework though, show your work. There are some really easy mental math ones. That's okay. You don't have to show it on every single problem. I'm a math teacher. I do things quickly in my head too sometimes. But I should see effort, and I should not just see answers. And if you haven't already checked out www.calcchat.com, check it out. It's cool. Lots of stuff for all the odds. But if I were to collect notebooks one day and check a particularly hard problem and see whether or not it looks exactly like CalChat, then we could be in some really big trouble. Does that make sense? Okay. Do your work, do it well, do it to the best of your ability. I will see you tomorrow. You guys have a few seconds to chill and hang out. We were going to start section 1, 2. We'll just wait until tomorrow to get there. But 1, 2 starts everything hopefully easy, but then it gets kind of hard kind of fast. So hang in there. Any questions? Logistics or otherwise? Yeah.
Why wasn't there example 2 on the
I have no idea. I might have just deleted one. Oh, it's from the book. So I copy and paste it. Sometimes I make up my own, but in these so they're like extra examples. Any other questions? Comments? How we doing? Spirals? How many of you guys are like, I actually might like the whole spiral thing? Don't worry. Some of you won't, some of you will. We'll just see how it goes. Thanks for being my guinea pig. So, all right, I'm stopping recording. You guys have 25 seconds to chill.
Hang on.